Hello viewers, in today's class we are going to discuss one important and conceptual definite integral involving signum function and modulus function, right? So here we'll evaluate this integral that is from -1 to 2, and here we have mod of x minus 1 and signum of x over 2, right? So in this definite integral, the integrand involves the two very important functions in mathematics, that is the signum function and mod function, right? So let us start. Now let us first call this integral as I, right? Okay, so before proceeding further, let us first quickly see the definition of signum function, right? Now see, signum of y is defined like this. Now signum of y takes the value plus 1 whenever y is greater than 0, right? And signum of y takes the value 0 when y is equal to 0, and signum of y is minus 1 whenever y is less than 0, right? Now if we replace y by x over 2, right? So let us replace y by x over 2. So what will happen? Signum of x over 2, uh, it is defined like this. So this is plus 1 whenever y is greater than 0. So now y is x over 2. So x over 2 is greater than 0, right? And signum of x over 2 takes the value 0 whenever x over 2 is equal to 0, and it takes the value minus 1 whenever x over 2 is less than 0, right? Now if we solve this inequality, then we'll simply get x greater than 0, and here we have the equation x over 2 is equal to 0. So this is x is equal to 0, and here we have x less than 0, right? So this is all about the definition of signum of x over 2, right? Now let us define the mod function, right? So here we have a mod of x minus 1, right? So mod of x minus 1 is positive x minus 1 whenever x minus 1 is greater than or equal to 0, right? Or we can say that x is greater than or equal to 1, right? And mod of x minus 1 is equal to negative of x minus 1 whenever we have x minus 1 is less than 0. It implies x less than 1, right? So these two definitions would be used while solving this integral, right? Now in the next section we will split this integral as a sum of three integrals, right? Now let us see the limits. Now here the lower limit is minus 1, right? So here we have minus 1, and the upper limit is 2, right? So here we can denote 2, and between minus 1 and 2, here we can write 0, and here we can write 1, right? So now what we will do, we'll write this integral I as a sum of first we'll write it as a sum of two integrals, right? So we can write I1 plus I2. Why we are writing I1 plus I2? See, first we'll go from minus 1 to 1, right? Minus 1 to 1. Why we are going from minus 1 to 1? Because see, here we have x less than 1, right? So first we'll take care of this mod function, right? So here we have x less than 1. So first we'll take the integral from minus 1 to 1, and here we'll write, see, when we go from minus 1 to 1, x is less than 1. So mod of x minus 1 is negative of x minus 1. So here we'll write negative of x minus 1, and we'll keep signum of x over 2 as such, right? So here we have signum of x over 2 and dx, right? And the next integral I2 can be written as from 1 to 2, right? So from 1 to 2, because here we have x greater than or equal to 1, right? So when x is greater than or equal to 1, mod of x minus 1 is positive x minus 1, right? And again, we'll take a signum of x over 2 as such, right? So here we'll write signum of x over 2 and dx. So the first step is to take care of the mod function, and due to this, this integral can be written as a sum of two integrals, right? Now we'll take care of this signum function. So now let us take these two integrals separately, right? So here we can now write this integral minus 1 to 1, and here we have minus x plus 1, and here we have signum of x over 2 dx, right? Okay, now let us further divide this integral as a sum of two integrals, right? So first we'll go from minus 1 to 0, right? So why we are going from minus 1 to 0? Because when we take the limits from minus 1 to 0, we have x less than 0, right? Because now we are taking the signum function, right? So we have minus 1 to 0, and here we have negative of x plus 1, and the signum of x over 2 will take the value minus 1 because x is less than 0. Because when we go from minus 1 to 0, all the x are less than 0. So here we can now write negative of 1 and dx, right? And then we'll go from 0 to 1, right? So when we go from 0 to 1, here we have minus x plus 1, and the signum of x over 2 would now take positive 1 value, right? So signum of x over 2 can be replaced by plus 1, because here see, x is greater than 0. Because when we go from 0 to 1, all the x are greater than 0. So signum of x over 2 can be replaced by plus 1, right? So now we have two very simple integrals. So now see, here we have the integral minus 1 to 0. Now we can multiply these two terms by minus 1. So we have again x minus 1 dx, and here we can write 0 to 1 and minus x plus 1 dx, right? Now we can simply solve the integrals. So here we have x square over 2 minus x, limits are from minus 1 to 0, and from here we have minus x square over 2 plus x, and limits are from 0 to 1. Now when we take 0, the entire term would become 0. So here we have 0 minus, then we'll take minus 1. So here we have minus 1 square is plus 1, and here we have plus 1, right? And here we'll take 1, so we have minus half plus 1. When we take 0, the entire term would become 0, and now this is minus 3 over 2, and this is half, right? So minus 3 plus 1 over 2, so we have minus 2 over 2, that is minus 1, right? So the value of this integral, that is I1, is equal to minus of 1, right? Now let us calculate this integral I2. So now when we take this integral, that is 1 to 2, and here we have x minus 1 and signum of x over 2 dx, right? Now see, here the limits are from 1 to 2. Now when we go from 1 to 2, all the x are positive, right? So x is greater than 0, so signum of x over 2 can take the value plus 1, right? So we have 1 to 2, here we have x minus 1, and here we have plus 1, right? And now we have the simple integral. This is x square over 2 minus x, and here we have 1 to 2, right? Now we can, when we substitute the limits, we'll get 4 over 2 minus 2, and here we have 1 square is 1, so we have half minus 1. So this is 2 minus 2, and here we have minus half, and this is 0, and this is plus half, right? So this is half. So the value of this integral is 1 over 2. So now the composite value of this integral I is I1 plus I2. So I1 is minus 1 and I2 is half, right? And minus 1 plus half is minus half, right? So viewers, the value of this integral is equal to minus half.